Hello everyone and welcome back. I am Mr. Cobalt, and today in this video I am going to be going over the second problem using mass percent as a conversion factor. So just remind you what a mass percent is. The mass percent of a substance is where you are given or you are finding how much or what fraction of the compound is due to a particular element, and then you're expressing that as a percentage. So let me remind you that a percentage, the general formula is the part divided by the whole multiplied by 100. So the percentage is out of 100, so that's what percent means, per 100. So if you know the mass percent, then what they're doing is you find the mass of whatever element you're interested in, X, divided by the mass of the compound multiplied by 100. In an earlier video, I used molar mass as an example. So if you assume 1 mole of the substance, you can figure out what the molar mass of the compound is if you are given the formula. And then you find out what the mass per 1 mole is for the element in that formula. And then you divide the two and you multiply by 100, and that gives you the mass percent. But what do you do when you're given the mass percent? So here in this problem, we're given the mass percent. And so we can use the mass percent as a conversion factor because we can create or we can translate that into a relationship. And like I said, since percent is per 100, then you just assume 100 grams of this substance. And so there you can have a relationship between the whole and the part in terms of mass. So you can relate the grams of the whole to the grams of the part, where the whole is assumed to be 100. So for example, in this example, I am told that iron 3 oxide is 69.94% iron by mass. So that gives me a relationship between iron, which is the part, and the whole, which is iron 3 oxide. So if iron 3 oxide is 69.94% of iron, then that means if I have 100 grams of my iron 3 oxide, then 69.94 grams of it is going to be iron. Okay, so then I have that relationship, so I can write that as 69.94 grams of iron will be equal to 100 grams of the iron 3 oxide. And so I can write this as a ratio of 69.94 to 100. And now I can use this as a conversion factor. One of the things I want to point out really quick is a problem like this requires that you know the names and the formulas of different substances or of ionic substances. So if you're not strong with naming ionic substances, you need to make sure you go back and review. So remember, iron 3 is the name of that iron ion, and 3 tells you the charge. So if I know the charge is +3, and then oxide is oxygen, and I know the oxygen has a -2 charge because it's in group 6, and the rule is 6 minus 8, it's the group number minus 8 gives you the charge. And then once I know the charge, I do my crisscross rule and I get the formula. If this is not quite clear to you, then go to the video earlier where I talked about how to go from the name to the formula in a video. So please go. I'll link that into the description. So here I have this. So again, when you're talking about the problem, when you're doing a problem like this word problem, you need to pull out the information, the relationships that they give you, because the relationships are going to be used as conversion factors. So the percent is something that they gave you, and then we can make that into a relationship out of 100 grams. So now we can use this as a conversion factor. And the question in the problem will always tell us where to end and where to begin. So the what part, the beginning of the question, whatever follows that is going to be our ending. That's where we're going to end our calculations. So what mass in grams of iron 3 oxide? So they want us to find the grams of iron 3 oxide. So I'm going to write my arrow down. So we need to get to a certain number of grams of iron 3 oxide. So that's where we're going to end. Where do we begin? Well, if we keep reading the question, it will tell us. So what mass in grams of iron 3 oxide what mass of iron 3 oxide has, or is, I think I forgot something in the problem. Contains, I forgot the word contains. How many grams contains, how many grams of iron 3 oxide contains this many grams of iron? So this is the number of grams of iron, that's where we need to begin. So we got to begin with the 58.7 grams of iron, and we need to convert that to grams of the iron 3 oxide. So again, here we're going from the part to the whole, and so we need a relationship of part to whole in order to make that conversion. And that's what the percentage gives us. It gives us a relationship between part and whole. So now we can start our problem. We're going to begin with grams of iron. So we got 58.7 grams of iron. We're going to put that over 1. There's no unit on the bottom. Because we just have grams of iron. And now we're going to multiply by our first conversion factor. So we need to go from grams of the part, iron, to grams of the whole. Okay, so now we can use our relationship. Here we have grams of iron related to grams of the whole, the iron 3 oxide. So we're going to use that relationship as a conversion factor. So I have grams of iron on the top. So I want grams of iron on the bottom. So I'm going to take this and put it on the bottom. So I have 69.94 grams of iron. And that means 100 grams of iron 3 oxide goes on top. So 100 grams of iron 3 oxide. Okay, so remember, the 3 refers to the charge on the iron, not the subscript. All right, so now grams of iron cancel out, and now I'm left with grams of the iron 3 oxide. So now that's what I want. That's what they're asking for. I am finished. This is a one-step problem. So now all I need to do is just take my calculator and calculate. So here I'm going to multiply across the top, divide by the bottom, and I should get my answer. So 58.7 multiplied by 100 divided by 69.94 equals, and that gives me 83.92908. 92908 grams, and it's grams of my iron 3 oxide. Iron 3 oxide. So that's the answer that I get from my calculator, but I can't keep all of these digits. So I have to figure out the number of sig figs I'm allowed to keep. So I got to go back to the numbers I multiplied and divided by. When I come here, I want to get rid of any of the numbers or relationships that are exact. Here, 100 to 69.94. This 100 is an exact number because it's by definition that That's what a percentage means. So if I have 69.94%, it's 69.94 out of 100. So I didn't measure the 100. So this will not count as number of sig figs, so we ignore that. But the 69.94, that's the percentage, that's a measure that we had. So that we need to look at. And then this is a measure. This is what we are given, 58.7 grams of iron. So that's measure 2. So we look at our sig figs. So this has 4 sig figs. This has 3 sig figs. So our answer should be have the same number of sig figs as the least number. And since the least number is 3, then we're only allowed 3. So we're going to cut it out 8, 3, 9. So 9, after the 9, everything goes away. The 2 is a 2, right? So that's less than 5, so that's going to stay a 9. So then the final answer is 83.9 grams of the iron 3 oxide. Okay, so that would be our final answer. I hope this was helpful. Let me know what you think in the comment section. So make a comment below. Tell me what you think. Is there anything else you would want me to go over? Please make sure that you ring the notification bell so you can be notified by other videos that I have. Subscribe to the channel as well, and share the video with your friends. Thank you for joining me, and I'll see you guys next time.